Fabulous. First things first, the Pythagorean theorem and the distance formula, which will eventually help us decide what our trig functions are worth. As a review, Pythagorean theorem is a squared plus b squared equal to c squared. We've been doing that since like 7th or 8th grade. We should know that one. The a, b, and c are the sides of a triangle, specifically a right triangle. Side length A is a leg, side length B is a leg, and side length C is always the hypotenuse. Now, right angles are the only ones that have hypotenuses, so Pythagorean theorem is for right angles only. We will also be determining distances on a coordinate grid. So we have the formula for distance, which we've done in this class / we've seen before. That's the formula for distance between 2 points. Check. Okay. Now, when we define our 6 trigonometric functions, we will start with an angle theta in the standard position, which we discussed last time, and choose any point P having these coordinates x and y on the terminal side of angle theta. So here's our angle. This is our terminal side, or this is our initial side. So we have this obtuse angle here. If we drop a perpendicular from the point straight down, it makes a y value because that's the height of this point. If we use this as another leg of a triangle, we have an x coordinate. So we have actually created what's called a reference triangle here for us to complete all of our trig functions for. The only thing we have to compute when we have a coordinate point is the length of the radius r. But since that's a distance from the origin to this point, we can simplify our distance formula from the origin to the point by plugging in zeros for the origin, which really simplifies down to this formula right here. The radius of a function is found by just taking the square root of x squared plus y squared. It is the distance formula, but by plugging in zeros, we like to ignore them. So it's x squared plus y squared square rooted. Now that's going to give us a number for the radius. So now we would have a number for the radius, we would have a number for the x value, and we would have a number for the y value. Once we have those 3 numbers, x, y, and radius, we can determine all 6 trigonometric functions. These 6 trig functions are as follows and defined as follows. This is one of the things I'm having you memorize. Sine of theta. Ooh, pet peeve of mine, by the way. Don't say sin theta. No, thank you. It is sine of theta. This is sine of theta. You find sine of theta by doing y divided by r. So whatever the number you have for y, divided by the number you have for the radius. This is called cosine of theta. Not cos theta, pet peeve. Cosine of theta. Cosine of theta is found by dividing the x value divided by my radius. Tangent of theta, not tan theta, tangent of theta is found by taking the ratio of the y value divided by the x value. Those are my 3 basic trig functions. If you do not have those words memorized, because it's just the abbreviations, this is sine, cosine, and tangent, if you want to write those words for yourself. There are 3 more trig functions that are just reciprocals of the original 3 trig functions. They are called cosecant, secant, and cotangent. That is how you pronounce them even when they're shortened. So don't say for this, that is cosecant. Don't say SEC, this is secant, it has a name. Don't say cot, that is cotangent. It's a pet peeve of mine. But we can also define these. They're just the reciprocal of the one right above them. I've paired them up with their buddy. So cosecant is really just flipping over sine. So instead of y over r, we have r over y. For secant, it is a flipped over version of cosine. So instead of x over r, it is r over x. And cotangent is the reciprocal of tangent. So instead of y over x, it is x over y. These 6 things we're going to have memorized because I'm going to ask you over and over again for the different values of these trig functions. So knowing what I'm asking for means you can just whip out the answer without having to look up all of the formulas. Super duper helpful. Fabulous. Now, you will have to refer back to this while you're memorizing it if you don't have these already memorized, but on the back, we're going to start using these to find all the values of the 6 trig functions. So, for example, in example 1, it says the terminal side of angle theta in standard position passes through the point 8, 15. So that is an x value, I already forgot what color. That is an x value of 8 and a y value of 15. So this is y. This is x. We want to find the values of the 6 different trigonometric functions for the angle theta. Like I said earlier, the only 3 things you need to be able to figure this out is x, which we know is 8, y, which we know is 15, and r, which as of this moment right now, we do not know r. But we have a little bitty formula for r. It is just the distance between the points and the origin, aka you will find the radius by doing the square root of 8 squared plus 15 squared. This is where we turn to our calculator. What is the square root of 8 squared plus 15 squared? Did your calculator return to you a nice pretty number? 17. Okay, fabulous. So we got that r is equal to 17. When the calculator gives us a pretty number, we're good to go. If it gave us a decimal, we'd have to do something else that we will get to later. Okay. So these are the 3 things I need to know to be able to determine all 6 trig functions. Once I have those 3, I just have to remember what order they go in. What I mean by that is, and I'm just going to draw a bar so we know this side is my answers. If I was doing sine of theta is the y divided by r. Cosine of theta is the x divided by r. It's theta. It's a Greek letter that represents angles. It's a 0. It looks like a 0 with a line through it, but it's not a 0. It's representative of an angle. In trig, we always use Greek letters to represent angles, so you'll see me use alpha, beta, and theta the most. Those are going to be the letters I use for, they're and lowercase Greek letters. If you look them up on a like keyboard, they're lowercase Greek letters. That was a good question. Tangent of theta, if we looked at our formula, says that it is the y over the x, so we have 15 over 8. If we keep going and we do the other 3, they're just the reciprocals. I find it easiest to do sine, cosine, and tangent first, because when I do cosecant, which matches up with sine, I just have to flip those numbers over, 17 over 15. When I do secant of theta, I just have to match it up with cosine and flip those numbers over. And when I do cotangent of theta, it is just the flipped over version of tangent. And there's the 6 trig functions, the values of the 6 trig functions. Comments, questions, concerns? Fabulous. You have example 2 to try. You have people at your table to work with if you get stuck on something. I'll give you a few minutes to work on that one. So when you set this one up, you are again given x and y, -3, -4. Make sure when you find the radius you're using parentheses appropriately if you're using a big yellow graphing calculator so that you don't accidentally square a negative number incorrectly. You should get 5 for this one, which means that we can then set up all 6 trig functions. To do sine of theta, it is y over r, so that's -4 over 5. Cosine of theta is x over r, and tangent of theta is y over x. When you do that one, though, I end up with -4 over -3. Hopefully you simplified that just to be +4 over +3, yeah? Because negative divided by negative is positive. Cool. Then cosecant, secant, and cotangent are the easy ones because after we've done all that hard work, we just remember that they're the flipped over versions. R over y, then r over x, and then x over y. Good? Okay, cool. Easy peasy, I gave you the coordinates, good to go. However, I don't always have to just give you the coordinates for you to be able to do all of this information. Example 3 says find the 6 trig functions of angle theta in standard position if the terminal side of theta is defined by x plus 2y equal to 0 and x is greater than or equal to 0. Be sure to rationalize any denominators if needed. Now, didn't give you a coordinate point, so we're going to have to find a coordinate point. Some things that we know to find this coordinate point is number 1, that x has to be positive. That's what this is telling me. We have to have a positive number for x. If that's the case, and this has to be a positive number, what can we conclude about y if they together equal 0? If x is definitely positive, and when I add it with this number, I get 0, what does that mean about y? I just straight up actually didn't hear what you said. It's definitely going to be negative, because if I have a positive number and then need to end back up at 0, I know that y is going to have to be negative. Okay, cool. Let's figure out what numbers would work here. If we take this little equation, x plus 2y equal to 0, and I solve it for y, that means this would be 2y equal to negative x, or y is equal to negative 1/2 of x. What's a very easy number that has a nice clean half that we can use? Okay, everything I said was right, but I did it backwards. 2 does have a nice pretty half, which means that that's going to be x, so that we can actually take half of x. So sorry, because we're plugging it in here. Right. Negative 1/2 of x means that y is equal to negative 1. That's what I totally meant to say the first time. So sorry. That means that we are going to use the coordinate point 2, negative 1, that's better, as my x and as my y. Once we get here, we now have the x and the y. We're going to be able to use them to find r. So to find r, we would just take the square root of the x squared plus the y squared. If you put this one in your calculator, when you press enter, you're going to get an ugly decimal. I don't want ugly decimals in these problems. If it comes out to a cute number, we're good to go. So when that happens, I want you to compute this without the square root. If we do 2 squared plus negative 1 squared, 2 squared is 4, negative 1 squared is 1, 4 plus 1 is 5. We're going to leave this in simplified radical form, meaning this is going to stay as square root 5, or radical 5. If you can reduce the radical, you will, taking out pairs, but for the most part, for the important part, you're going to keep the radical there, no decimals. So I have the following information. I have that x is equal to 2, y is equal to negative 1, and r is equal to square root 5. We're going to be able to use this information to find all 6 trig functions now that we've determined what the coordinate point and the radius is. Now this question does say that we will need to rationalize any denominators if needed. So if we're trying to rationalize denominators, we're going to cut down here for a second to make sure we know what that means. You are not allowed to leave radicals in the denominator. Some textbooks allow you to. We are not doing that. So here's what we do to get rid of it. It says radicals should not be left in the denominator. The fraction 1 over root a can be rationalized by multiplying square root of a over square root of a and reducing the fraction. So for example, I wonder why I picked square root 5 in my example. If I have 1 over square root 5, I will multiply it by square root 5 over square root 5. When I'm multiplying fractions, I do top times top and bottom times bottom. 1 times square root 5 is square root 5. Square root 5 times square root 5 is square root of 25, because 5 times 5 is 25. Well, what's the square root of 25? 5. So the bottom no longer has a radical, and the number square root 5 over 5 is a better answer. These two numbers right here are mathematically equivalent, but we like this version better. So we're going to rationalize denominators when we need to. So if you put a radical in the bottom, you got to get it out. Okay. Let's write our 6 trig functions, making sure we rationalize denominators. If we start with sine, sine of theta is the y value, -1, divided by the r value. Problem, I just put a radical in the denominator. Times it by the square root of 5, which means this will end up being square root of 5, negative square root of 5 over 5. You don't have to show me the work for rationalizing a denominator. I showed you once so you know what I'm doing when I do that. Basically, take the number out of the square root in the bottom and put the whole square root in the top. If we go to do cosine, cosine of theta, when we write it down as x divided by r, oop, I put a square root in the bottom again. So take it out of the bottom, put it in the top, and then just take the number out of the bottom. That is that is the shortcut for rationalizing denominators. For tangent of theta is the y divided by the x, so we get -1/2. For me especially, the reason why I wanted to at least show this step in sine and cosine is because it actually makes finding their reciprocals really easy. If we find cosecant, it is the reciprocal of sine. Don't use the reciprocal of this number because then you'd have to rationalize the denominator again. Do this one. Flip this one over, we end up with square root of 5 over -1, which is really just negative square root 5. For secant, which is the reciprocal of cosine, we're not going to flip over to square root 5 over 5. We're going to flip over the other one. This is square root of 5 over 2. And last but not least, for cotangent of theta, we flip over -1/2. That means we do 2 over -1, or just a cute little -2. Comments, questions, concerns on that one? I know I kind of fumbled the beginning, so if that's where we need to zoom in for questions, we can.
You just plugged in a number to x that could be half.
Basically, yeah. You can use, because it's a ratio, it would reduce out if you had too big of a number. So as long as it fits that, like if x is positive and if you added them together and doubled y and you got 0, you'd be fine. So we could have used 4 and -2. It would have reduced back down, my trig functions would have reduced back down to this, so we want to use a small coordinate, but as long as it fits what it tells you, it will work. Are we good? Let's flip it over. All right. Now, we talked about these quadrantial angles last time. They're the angles that end up being on your axes. So your 90 degrees, 180 degrees, 270 degrees, 360 degrees, all of those around. These are important to be wary of because when you are on one of the axes, your coordinates, one of them is 0. Do we see that? So when we're writing our trig functions, that means one of the numbers we're plugging in is 0. And you want to be careful because when you put a 0 in the denominator, what happens? Yeah, you're knocked out. It's undefined. That's a no-no. So if you put a 0 in the denominator, you stop what you're doing and you write the word undefined instead. Okay, so this really comes in handy when you have those sign factor, your angles are these quadrantial angles. You have to already be wary that something is probably going to be undefined because you're going to plug in a 0 somewhere. Now, as a hint, in the calculator, number 1, you will need to make sure you're in degree mode for these first few chapters. The class right before you is going to be working in radians, so you will always have to switch your calculator back to degrees, so please be ready for that. Also, when you reset a calculator, it resets to radian mode, so you will always need to double check that you're in degree mode for my class. But in degree mode, it returns the correct values for sine and cosine. So if we said sine of 90, you would get 1. Cosine of 90, you would get 0. That's correct. However, if you typed tangent of 90 in, it would tell you error. If you're using your calculator as a tool and you get the word error, that is when you know that you got an undefined value. You put a 0 in the denominator, technically. I think the error message that pops up is literally error undefined, but if you get an error, it's because that trig function is undefined there. All right, so let's make sure we understand this. Let's find the values for the 6 trig functions for each angle. First up is an angle of 90 degrees. If we think about an angle of 90 degrees, it looks like this. Okay? If you're up here on the y-axis and above the x-axis, your coordinate point is going to have a positive x value and it's going to have a 0 for an x value and any positive number for y. I'm going to make that be 1 because it's an easy number to use. So our quadrantial angles.
They always go counterclockwise?
Correct. Yes, positive angles go counterclockwise. You can go clockwise. That just means you're doing a negative angle. So we just try to stay positive as much as possible in life and in math. Okay, so if this is x and this is y, what is r? That would be theta, but yes, 1. The reason we got that is because if we found, like we'd been doing for the other problems, the x value squared and the y value squared, 0 squared is 0, 1 squared is 1, the square root of 1 is still 1. Okay, so we have sine of theta. What are the letters I'm using for sine of theta?
X and R. I mean Y and R.
Y and R. So this is 1 over 1, aka 1. For cosine of theta, what are the letters I'm using?
X and R.
X and R. So that would be 0 over 1. Do I need to panic when I do 0 over 1?
No.
No, that's just 0. What about tangent of theta? What letters am I using?
1 over 0.
Yeah, y over x, so 1 over 0. Uh-oh, I just put a 0 in the denominator. What does that mean? Undefined. I know y'all might be out of room. I'm just going to keep going down, though. If I do cosecant, which is the reciprocal of sine, 1 over 1 is still 1 when you flip it over. If I do secant of theta, which is the reciprocal of cosine, I would be doing 1 over 0. Uh-oh. What happens when I do 1 over 0? Undefined. When I go to do cotangent, I would flip over the number from tangent, which is 0 over 1. That one's okay. That's just 0. Make this look nicer. Do the same colors I've been doing. Okay. Cool. I'll help you get started with B, and then I'm going to let you finish it. It says do the same thing. Find the 6 trig functions for an angle in standard position with a terminal side passing through -3, 0. If we think about what that looks like, if you have a coordinate point, -3, 0, 1, 2, 3. This is -3, 0. So it's on one of my axes. It's on the x-axis, but on the negative side. So for this one, since I am given x and y, it's actually pretty easy. We know x is -3. We know y is 0. How do you find r? It's actually 3 as well. Yeah, because if we went to go do our formula, this would be -3 squared plus 0 squared, which ends up just being 3. Also, if that's a circle, our radius goes from the origin to the side. That's 3 units. Distance is always positive. I'm going to leave you here. I want you to give me all 6 trig functions. Sine, cosine, tangent, cosecant, secant, and cotangent. Okay, if you want to give it a quick check. We should have gotten sine is 0, cosine of theta is -1, tangent of theta is 0, cosecant is undefined, secant is 1, and cotangent is undefined. How'd we do? Okay, fabulous. So the last page here is just a little bit more information to kind of summarize what we've learned today into a table. You don't have to memorize this table, but if you think really well by seeing things in tables, it might be helpful for you. In our conditions for undefined values, since we noticed that there were only some types of functions that could get undefined, we can identify the terminal sides. If we can identify the terminal side of the quadrantal angle and what quadrant it's in, then we would know which ones are undefined. It says, if the terminal side of a quadrantal angle lies along the y-axis. For my y-axis, that is the angle degrees of 90 degrees and 270 degrees. Then that means that tangent and secant are the ones that are going to be undefined. If the terminal sidelong is on the x-axis, which is 0 degrees, 180 degrees, and 360 degrees, and any rotation again of those, then cotangent and cosecant functions are undefined. I don't have this particularly memorized when I do this. I just think about what's in the denominator. If r is in the denominator, it's never going to be undefined. So sine and cosine will never be undefined. But if x and y are in the denominator, then it depends on which one of those values is 0. That makes it undefined. So here you have an image that kind of goes with this. So when we're on my y-axis, that means we are talking about the 90 and the 270. Notice on both of those, the same two functions are the ones that are undefined. That's tangent and secant. When we're on my x-axis, which is 0, 180, and 360, probably could have done a better job highlighting, then the same two trig functions are also undefined, cotangent and cosecant. This last little caution I already said today, but remember one of the most common errors involving calculators in trigonometry was when you're not in the correct mode. For chapter 1, we are in degree mode. And like I said, AP Pre-Cal before you guys is working only in radians throughout the entire semester. So make sure you open your calculator every time and make sure it's highlighted on degree when we're in chapters dealing with degrees. Just don't forget about that.